In this problem, we're given the derivative of u of t is equal to u divided by t to the 1/3 power. We're also given that u of 1 is equal to 216, and we're asked to find the solution to the initial value problem. Okay, so on this one, we have on the right side here, we have mixed variables. So we're going to want to try to get rid of those. Since we have the derivative of u on the left side, which can be written as du, let's try to get the u to be over there on the left side and keep the t on the right side. Okay, so the first thing I want to do in order to accomplish that is split up this fraction here. Instead of having u divided by t all to the 1/3 power, I'll write it as u to the 1/3 divided by t to the 1/3. Okay, and when I do that, that means now I can divide, or we'll just say multiply both sides by 1 over u to the 1/3 times 1 over u to the 1/3, both sides. Okay, essentially dividing it out because it'll make it cancel on the right side. Okay, and now it's over there with the u prime. So we'll get u prime of t, or the derivative of u, divided by u to the 1/3 is equal to 1 over t to the 1/3. Okay. Now let's go ahead and bring those up and make the exponents negative. So we'll bring those up to the top. So this becomes u to the negative 1/3 times u prime of t is equal to t to the negative 1/3. Okay. Now I'm going to rewrite the u prime of t as just du, and then I'm going to integrate both sides. So u to the negative 1/3 du is equal to t to the negative 1/3. And then I'll integrate both sides and put a little dt on that side. Okay, now we've got it separated, and we can integrate both sides. So you add 1 to the exponent and divide by that. So this becomes u to the 2/3. And remember, you have to divide by this exponent. So if we're dividing by 2/3, that's multiplying by 3/2. Okay, equals, and the t is the exact same thing. It's just a t instead of a u. So also 3t to the 2/3 divided by 2, and then plus c. All right, getting close to done. Let's get rid of the 3/2 on both sides. We can multiply both sides by 2/3. You can even multiply the c by 2/3. We're just going to leave it at c, though. We don't care. It's a constant. We don't know what the constant is yet, but we'll find that out soon. So u to the 2/3 is equal to t to the 2/3 plus c. So I got rid of the 3/2. And now I can use my initial condition. Okay, this goes in for t. This goes in for u. Okay, because the function is u of t is equal to whatever the function is. So this goes in for t. So 216 to the 2/3 power is equal to 1 to the 2/3 plus c. Okay, 216 to the 2/3 power, that's essentially taking the cube root and then squaring it. Okay, so you'll get 36 if you do that, equals 1 plus c. Subtract the 1 and you get 35 is equal to c. So we figured out our c, and now we just plug it back into here where we had the equation. Okay, so that gives us u to the 2/3 plus, equals t to the 2/3 plus 35. Okay, now we want to solve for u because this is a function of u. So we do the opposite. We raise everything to the opposite power of 2/3. The opposite power of 2/3 is 3/2. So this becomes u is equal to t to the 2/3 power plus 35 to the 3/2 power. Okay, so we raised everything to the 3/2 because when you raise this to the 3/2, the 3 cancels and the 2 cancels and it's gone. So we raise the other side to the 3/2 as well. This is good enough for most, but if you wanted to write this in radical and exponential form, it would be the square root of t to the 2/3 plus 35 to the 3rd power. And you could even do the same thing inside there, but I'm going to leave it alone at that point. And that's it.